Today we shall be discussing about system design for the booking. And by booking, we can mean any booking, but in general, to make things easier, we will mean ticket booking. Or for example, book my show. So book my show, or your ease my trip, or say booking.com, they come under different categories, but they have the same problem. This is related to events and tickets. Today there is something called District by Zomato as well. These are for your flight tickets, and this is for hotel. All of them follow the same problem. The problem is that there is a given inventory. Inventory means collection of resources, and in this case, if it is tickets, then collection of seats for a particular theater. This is a T1 with a booking show of, let's say, 11 a.m. And for this, users, everyone wants to request. So there is user 1, user 2, user 3. We have to allocate seats as per their choice. Say user 1 has selected 2 seats, 3 seats, user 3 has selected 1 seat. Similarly, we have to fill up the inventory, and we want to make sure that user 1 and user 2, they don't select the same thing. That is, they can have a choice, but if they are trying to choose the same seat, we should avoid that collision. So, trying to understand the requirements, I have already written read greater than write. This is one of the particular requirements in it, and here the ratio is around 100:1. We will discuss the numbers in some time, but then it is one of the requirements for this system design. It should be highly consistent. What that it means, whenever we are seeing the state in the DB for any particular seat, it should reflect the real truth. That means, in general, a seat is available or it is booked. If it is available, everyone should be seeing it as available. If somebody has booked it, then it should reflect that booked state properly. It also invertly means that if a user is making a payment and the payment has failed, we should respect it and refund it, and the transition from available to booked has to also be reverted back at the same time. If there is a success in the payment, but still it is not showing booked, we don't want this thing to happen. This means the write to the DB has failed, and again we have to revert back from available. Basically here it was available and it did not get booked. We have a choice. We either mark it as booked or we revert back and do a full refund. But I will come here and discuss that what exactly happened that it could not go from available to booked, and we actually have to go via refund part, but these are in the next steps. The next part is no double booking. So it's as simple as when two different users, for example, this is your seat A1 and then there is seat A2. A1, A2 would be in parallel. So this is your A1 and this is your A2 and this is your A3. This is your seat matrix. Color change, and then this makes more sense. And say I want to book 1 and 2. I selected these, and then there is some user, this is user 1 who came with the choice of A1 and A2, and then there is user 2 who comes with the choice of A2 and A3. Now because already user 1 has started booking and has been making these bookings, and at the same time user 2 starts their booking, if user 1 succeeds with A2 being the common seat, then user 2 should not be allowed to make that booking, because the seat 2 is the common resource which already has been acquired, or in this case has been given to already user 1. So again, kind of repeating in short, if two users are coming with same seat request at the same time, then the first come first serve scenario should win in case the entire transaction has been committed. Again, these words, if are new to you, I will come and repeat in the later parts of the design that what I'm trying to say. So this is what we mean by no double booking. Handle abandoned cart. Okay, this is another problem. When we will try to solve the double booking problem, we will fall into the abandoned cart problem as well. As simple as, say A has started the booking, or for example, in this case user 1, A is actually the seat row. You have started the booking and you have gone to the payment page, and then you have declined the payment altogether. That is, you either exited the application or you have done a back. So whatever mechanism we were doing to help with the double booking system, that will create a problem of abandoned cart, and we have to handle that as well. What it is, again, we'll come to know in the system design deep dive then when we'll be doing. And then again, the notorious thundering herd problem. It's same like when, let's say, Avengers or any kind of, for example, now Spider-Man movie is going to be released, so the pre-booking sales will start, or let's say immediately there is a lot of for example, FIFA World Cup, and it's not happening immediately, but whenever the seats had launched, then there was a seat matrix, all of it, and it was open to the entire world. So let's say 10 million requests hitting in one particular time, it will choke any kind of system. That is when we say thundering herd, like the entire crowd starts hitting your request to the servers. Then what do? We'll be discussing all of these in our next set. Before we start deep diving into what these are, let's first have a very general high level overview on how our seat booking application like Book My Show in general looks like. So to begin with, we'll have our 5 tabs. I'm basically saying that we will first have an access to our seats. Then we will be looking at all the movies, and by default there will be a search place, and then let's say we have chosen Avengers and it's today's date. Then we have to select a particular time slot, and it is for a given theater. Then we see the seat matrix, the important part. Then we select, let's say 1, 2, or how many seats, whatever we want. Some are booked, like in the matrix we are seeing some already booked, and whichever are free we give our choice. Then we fill up we get the payment page, we fill all the necessary details, we click on pay now, Then we see that the payment happens, and then we get a response, a next page called booked, and eventually we get a ticket mail or WhatsApp notification, whatever, saying that these are the tickets. And yes, there we go. So say you are a user, and let me change my pen. You are making a request. Now the requests are kind of bit different, and in this kind of approach we need to really understand what is our choke point. We are doing two kinds of things: one, viewing or searching of the movies or like events, and one is booking of the events. So these two things, out of which we really want to prevent a double booking scenario, which is the booking of the events. And we also know that, let's say there are typically 1 million or 10 power 6 users online at a given time on a Book My Show, or if not Book My Show, let's say any kind of a event floating platform. So if they're online in a day, most of them will not be actually booking the events. Most of them will be viewing the events. And a view is also distributed into two parts: searching for the movies by name, date, whatever filter is there, city, theater, etc. Looking at seat matrix. This part is also another aspect. Once someone has selected the seats in the seat matrix, then they finally go towards the booking of the events. So again, the main reason that we need to kind of dissect and segregate between each of these flows is, once we have understood that what all are part of our viewing event, like we are searching for the movies, then we are looking for a particular movie which we have filtered out. Let's say we have got these movies as per this particular filters. Then looking at that, we finally are presented the seat matrix for that given time. Then we select particular seat, and that is when the actual booking flow starts. So what we can do is, we generally create 3 different or 4 different, that number n varies, but what we will do is, we have still not designed the actual services, but what we will do in general is, there will be a search service very separate. There will be a entire CRUD part of the event from the admin side. Like basically these movies have to be provided, like have to be onboarded by the theaters. For example, there is theater 1, theater 2 in particular city, let's say Chennai or Hyderabad or Delhi. Each individual theater, they have to fill up all the details of when and where, what shows they are floating and everything. This will be one service. There will be a booking service, and then there will be another. Actually, we can dissolve it to a search service at this point. This is much more simpler. Why so? The point from admin side, even say there are n number of theaters, even if they are doing all the dedicated task of updating information respective to their theaters, it will never be a choke point for us. We have already segregated it out. And to be precise, this is called the theater management system. And Book My Show or any kind of such event platform, they provide their own TMS, but they also allow that there is a concept of third party or external. So for example, this is not part of this entire system design, but just to give a clarity, let's say there are 2 theaters, theater 1 and theater 2. This is part of the Book My Show ecosystem, so I will tell it as BMS. Now they are using the TMS or theater management service provided by the Book My Show, and this one is using a TMS by another third party. In this case, they have their own inventory. This one, so this will be represented by its own DB, and here it is managed completely by Book My Show, so it is Book My Show's DB. Now the theater 2, it has to float some part of its seat, so basically this will be represented in their third party's DB. They will have to then make a connection. Basically these are there are only a few TMS service providers in India or in general in the world, so they provide their own API so that they can collaborate and kind of synchronize between what seats are available in booking for at the theater itself, which are provided to the external seats, or how much of all is floated around, all these nuances. But we are actually not focusing on these, because internally everyone has to only make sure that these particular requirements are met. Okay, now that we have spoken a lot kind of off topic, but again, these are some things people generally tend to miss out in discussions, but you guys should kind of be aware of these concepts as well, and it might have also occurred that you guys might have thought of. Now that we know what are the major actors or components over here, the search service, the crude part of the admin, and then we have the booking service, let's also do a deep dive for the API part as well. In general, I don't go much into the API because the system design itself is very huge in itself, and our main focus is on the different components. I will also do the same over here as well, but because eventually you guys will see that, I'll just give a brief here. that there are only two paths. One is the read path and the write path, and the write path will have only 2 or 3 major components, one DB and then one caching mechanism over here, and if not cache, anything which makes writes to the DB in case of a booking, because the writes are in case of booking only, and the writes are with respect to user. So when a user is doing write, it is like an intent to book or finally booking. We just want to avoid those conflicts happening, and we have to break we have to resolve that thundering herd problem. So I will be introducing a queue. These are very much overall picture that I'm saying. But what I'm trying to say is there will be so less components over here that it gives us a windway that we can also discuss about an APIs over here, which are also again lightweight. Book My Show or any kind of booking system is not that heavy in terms of too much nuances. It's more like just understanding properly that where is the major contention point. So having said all these things, so first of all, we are obviously easily we can go with the REST API structure. Some important APIs that are coming to my mind immediately are like, this is our get movies part. Immediately when our home screen loads, a lot of movies get populated. This is happening via this call. Then the other thing we can do is get the show times. So for a particular movie, when we have chosen that particular movie, then we go with the movie ID. Don't mind my handwriting here because I'm trying to kind of write it very fast. And then we have our show time. This is one particular API. We get all the shows with respect to this particular movie ID. Then we have another get. So again, you will be observing a pattern. Most of them are gets, shows. Then we can do a show ID and then seats. So basically in the response that we get over here, it will be a list of different shows. So from here, one of the show IDs will be passed here, and then we will get for the seats. And at this point, the response of the seats is basically a seat matrix. So you can consider it something like this. There will be a seats and it is an array. And in that we will have different objects, the seat ID, the row number. Basically these are identifiers. From this you can understand, let's say A1, and this is a hex value of, let's say, in this case I'm saying it A1, but again a unique identifier. And type will be like standard, premium, whatever it is. And a status, this is the main part. Let's say in this case this is available. And similarly there will be multiple such seats. So Now this status, at this point I will already tell you, and this is kind of pattern. For now, let's assume there are two things, available and booked. This is actually the point of problem. We'll have to introduce a third state as well, but let's assume for now we have available and booked. I'll discuss further all the necessary parts and then come back and modify it once we understand that what exactly the problem has happened. Now after all the get parts, let's see now, once say user has given their intent of say A1 and A2, that is the seats they want to book, we will need a post endpoint. So we will do shows with the show ID and reserve. So now that I have already said reserve, I will write the reserve over here, but there is a reason why reserve has come into picture. But let's go forward with this. Reserve is basically an intent to book. It's not yet booked. This thing you need to keep in mind. And somewhere the request structure will look something like the seat ID and the different seat IDs, like the ones that I had mentioned over here, the particular seat ID, you can pass it over here, A1, A2. That's it. What about the user ID? Obviously, in a post request, the user ID will be coming from the header in the JWT, and there we will have the user ID in place. The next part would be what happens after this. Actually, because reserve is in place, the response to it. Now, this is the request body. The response body would look something like this. There will be a reservation ID, show ID. I mean, obviously the other resources, for example, the show ID, booking ID, I'm not saying, but the main thing is the reservation ID and status, like if it has been accepted, so reserved. Now there are other things also, like I think I should give it a dedicated segment. Let me move it to a new page. Some more important parts would be like the seats and obviously total amount. This, so this and this are the more important part, and also expires at and the status. In case you guys might not have noticed, but there is a timer through which you will have the opportunity. So in this page, when you have seen the you have basically moved by providing these seat options. From this point onwards, there will be, it responds back saying that okay, these seats are reserved, make payment. Basically the UI will differ, kind of like either here itself you will have the opportunity to choose, or in the next point where you make a payment, then the opportunity comes here. But the point is, from this point onwards, the actual booking will start. So booking will be something of this format. How to identify the booking? It is by the reservation ID, and the total amount here will be calculated based on the seat and the price multiplier and everything else. Expires at is governing till when this entire payment can be done, like this reservation will be held, and the status is reserved. It's basically saying coming back with a response. At this point, some of the response codes that can be present are 409, 400, and 429. This is when there is a conflict. As I had explained earlier here, that in case the diagram is lost, I'll just say when user 1 and user 2, it has A1 and A2 in its request, and it has A2 and A3. The conflict point is A2, then the 409 will be responded back. If it is a bad request, then 400 comes, like somehow we did an API call instead of the UI call, and then the seed ID does not exist or whatever invalid show. And then there is 429, too many requests. This is the rate limiter hitting. In general, I don't discuss about it, but again, as I repeat, that this is a very lightweight system, so kind of focusing on the response codes are also good. Now, something else we can also do is in the 409, we should also get in response what were the conflict points. So I will return in response that A2 ID seat ID was the point of conflict. Then what in the UI user will get to see is that, okay, this is the particular seat that was conflict. A1 is not the conflict, A2 is the point of conflict, then maybe I should go with A3. So that way it helps when returning back the response. We should be thoughtful about it. So we have seen already the post for intent to book. Now finally we will be coming at the final leg, which is confirming the booking, and it will be simple as bookings. The body for this will be having the reservation ID, the payment method, like whatever option we had chosen, and payment token. Now what this token is, I'll come to it later, but generally this is a token which is generated during the payment mechanism as part of the idempotency. Reservation ID is something that we have done. Token is the time of the payment, unique token getting created, and payment method is, again, you guys know, it could be card, it could be today there is UPI. In card also exactly which kind of card, debit or credit. I'm not going into those details. This is the request body, and obviously the response will be the exact thing. By exact I mean some parts of it will be repeated, and let me just write it down over here. The booking ID, the status, the tickets, so the different tickets, A1, A2 or whatever it is, and generally we have a QR code also in Book My Show. I'm not going into that nitty-gritty details, and the total paid. So far we have been discussing about the different APIs. As again I said, the main thing to note is mostly there are get calls. There is one part which is the post call, which is first to make an intent to reserve, and the final part, once we move forward, then we go for booking. This way we have kind of segregated and isolated in the booking part also that one request of booking will come is to reserve, and one request will come to actually make payment. Again, why did we do it will come down below when we are discussing about the actual system design at this point. Here we will discuss now that as part of two things, one is the read part and the write path, what different kinds of thought process we have to do. Now in the read path, simple, user makes a query via the API/load balancer, again API gateway, LB. This is the user making a read request or any of the get request. So first of all of the movie items or anything that are present, like the poster of the movie is the poster, and then the trailer at times, whatever their heavy metadata, that will be coming from our CDN. I mean, I drew it as a cloud, but let's not go into the diagram. Those things will be getting served directly from the CDN itself. Now we will be hitting our Elasticsearch. Obviously, the kind of query, it again is a flavor. If we know that exactly what kind of search we are doing, if it is not keyword search, for example, and it is very filter based search, like already filter options are present, we can do a DB query as well, not an issue. So if it is only city based filtering or say tag based filtering or etc, we could do a query, but rather Elasticsearch helps us a lot. It helps because there is important segregation that we've already did. Rather than hitting our actual DB, we have indexed it into our Elasticsearch. I mean, this is also a DB only, but I will write it as Elasticsearch DB or Elasticsearch actually. We have indexed all our information via cron job from our actual DB, and what the DBs, I'll come into that choice as well. To give a very high level overview on how Elasticsearch will also help out rather than doing a DB query, the main concept is, or main trick is that when we are doing keyword based search, or in general too many tag based kind of search, first of all, if let's say we were choosing this kind of a DB or like our SQL kind of a DB, we have to put a tags column and we have to add different tags, like tags in this case genre, horror, comedy, etc. A film can have multiple tags as well, say another is rom-com or romance in this case. The typical SQL query that we would be doing is like a where clause and tags in, and we'll pass all those options. SQL query, what it will do, it will go and scan all the list of columns over here, and then it will try to find out, okay, this movie has these all things. So it will take a lot of time. To give you an idea of the number of QPS or requests that are coming, as I said earlier, imagine 10 to the power 6 booking requests and that too in the entire day, which is like roughly 10.5 seconds requests, it's roughly equal to 10 QPS that we are hitting. Still, 10 QPS is a very normal load. Actually, the problem is when peak during the weekends generally, which is the human behavior when people are generally booking tickets, would be 20 times this, or even 10 times. The magnitude is like 100 QPS we are hitting at this point unnecessarily, and that too there are so many movies. The problem is not even QPS at this point, the problem is how many movies are there. Throughout there are like a million movies. Even if we like put a lot of where conditions that this problem is city, we put a filter of city or so and so, but still the amount of movies or events that are present and that has to be scanned around, they are not millions for a given day, agreed, but still because we have to unnecessarily go and scan in these cases, we don't want this to happen, and rather in the Elasticsearch we have the concept of inverted document. So inverted index, I've already discussed about it in my prior videos, but inverted index is more like, now what I will do for, if in my Elasticsearch console I have to basically in the Elasticsearch DB when setting it up I have to mention in the configuration schema. This is also like it requires its own deep dive, but generally what we will be doing a post call to the Elasticsearch end and putting the configuration, adding the particular not tags but actual indexing points. And in this case I choose my tags. So under horror there will be movie 1, movie 2. Under comedy there again will be movie 1, say. Under romance there is movie 3. Somebody choosing a tag of horror and comedy, there will be a horror and comedy. It will be an intersection of these two sets. So M1, M2 intersection M1, M1 will come out as a result. It's a very fast operation. Rather than going and scanning every movie and giving out the value, rather it's more towards going and finding in inverted index format that okay, these are my indices. I go and check that okay, horror is this. I only get this particular set, I intersect it with this set, or in case sometimes intersection is also not needed if the filter is not that complicated. So Elasticsearch wins this case. So we have sorted out one part till now. To make it better diagram, I write it over here as search service. This will be coming from our Elasticsearch, and at times the search will be so pretty common. So generally user 1, user 2, multiple users are searching for almost same type of filter queries only in general, or even by the movie name itself. So we can also put a cache over here. So first it will go and hit the cache. In case the cache is empty, so the server will do a request from the Elasticsearch database, and then it will fill up the cache. So we have completed one part of our read request. So going up, we are able to serve this. We are able to serve even the show times of the movies actually. This was mostly via the search service. Even this can be also done via the search service. Coming to the seats part actually, this is a bit interesting. Now seat is something, why we cannot directly go towards Elasticsearch is because the main purpose here was index, inverted index kind of thing, which we have already fulfilled our purpose. Seat is basically a grid-like structure. In at least in movies, it's a grid-like seating matrix pattern, or there is a theater layout. Here you have the theater, then you have some seats over here, some seats in this row, this part is empty. So basically, if not grid, it has its own layout structure and everything. And in the DB also, it will be stored in a separate format. So first I have to actually discuss about the DB choice, how we are storing it in the DB, kind of a high level overview of the schema structure that we are going with. Then we will be actually able to talk about how we are fulfilling this particular request of get. Let me copy it because too many times up and down we are doing. So there we go. So as we were discussing about this seat part and how we have to serve it for the DB, because DB becomes the initial point on how we are storing the seats, and choosing the DB is becoming very straightforward over here. Our main problem is that we have to make it highly consistent or strongly consistent. That is, a seat sold twice is a failure for us. So because of strong consistency, which is part of our ACID in our database, we will go with a SQL DB. There is no other thought process towards it. But then how do we serve the seats out of it is something pretty interesting topic. To be very frank over here, this is our SQL DB, or let's say Postgres or whatever, MySQL, I'm not going into the depth of it. We actually do not query directly into our DB also for our seat matrix. Rather, we'll be using a Redis bitset. Why bitset? Again, bitset is a dedicated structure. It is actually a specialized structure. So it's something like this. Say there are 16 seats total. Obviously, there will be more than that. You represent it in an array. It's not even an array. It's actually a representation of multiple bits. So 0, 0, 0 like this. Let's say you have 16 bits. This is basically hexadecimal representation. I will basically break it into sets of different 16. But having said that, not going into the complexity, if I have to represent a seat is booked or not, I just set it as 1 over here. I set 1, whichever seats are booked. Now there are multiple Redis operations for doing the query. For example, get bit. Directly we can say, and we store it something like the show. Okay, I'll change the pen. So get bit, and then the show, the ID of the show, and then the seats, and in that we call the offset Offset is nothing but the seat. So here, this seat, and this is when we put our particular seat ID, for example 5, then our response will be 1, and if we are put 3, then our response will be 0. So yeah, accordingly. So now to again give a brief idea, we had our user over here. User had done a read request in this case for the seats finally. So we have our normal SQL DB. We have over here our Elasticsearch. Obviously, we had our search service, which was serving query from our Elasticsearch. Now we have our seat service, the point from where the seating mechanism starts. This request has gone over here, the get, in case you guys don't remember, then this is this get shows, show ID, seats. It will first hit the SQL, it will basically look for the seats table. I will come into the design of the entire DB just after this topic. So the seats table, it will do a query, and it will then fill up the Redis cache. I will draw it with a red pen as usual. This will be your bit field format of storage. So at one point it will be a cold hit, then it will fill up this cache, and from this point onwards all this will be served from the Redis bitfield itself directly. Now obviously there will be a completely different write path over here which will make modifications to this particular seats table, and this is the exact table which will be a hot table where all the different contentions or bookings and everything will be happening. Then this mechanism has to make an update on the Redis bitfield as well, and will come actually. So we have actually started evolving our system. The main idea why I explained so much in depth here was to actually give you an idea that how we build up a system from scratch based on different points that we are solving one after the other. Now having said these two parts, we will start coming into discussing first about the different tables or the schema structure of our DB. So DB schema structure, and this is not that of a major thingy, but because again it will be pretty interesting to see that how we store different items, and specifically the seat table, and then after that all the different parts of the system design we can carry on forward. And all right, here we go. So this is overall the necessary tables that are sufficient enough to discuss about the current design that we are talking about. The main things are our theater, screen, shows, seats, movies, booking, and tickets. Now coming on to our basic general flow. So this is the movie with all the respective fields, movie ID, title. You guys can pause your screen and have enough look at it, but I will also describe that how things are getting linked together. So let's say we have come out to our theaters. So for a particular theater that we have selected, we get to see different screens. So here for 1T1, we see screen and for different show timings. So now for different screens, we have different shows, like that's the start time and end time, by which for particular screen we get to know. Also for one particular show, we have different seats. Now this is the important part. Now before coming to why seats is important, say now after the seats has gone into a booked state, so the booking ID is created. So as I had discussed earlier, we have different status: available, reserved, and booked. I'm talking about the book part. So when it's booked, then we create a booking ID entry, and booked is equivalent to making a payment. This is only when the payment is successful, then we create an entry in our DB. So in the booking we enter all the necessary details, and this is the final ticket entry. Once a booking is created, we also trigger a ticket entry, so it has its own unique ID and then the booking reference ID. Let me draw that. Yeah, this is a 1:1, 1-to-1 relation. So obviously every booking is related to one particular ticket, and then there are seat ID. It's not actually 1-to-1 now that I have said it, it's actually 1-to-many, because different seats come under the same booking ID. It's all have their own different QR code. You must have seen that thing. Before moving forward, let's also take a small look at a few of the columns. So you can take a pause at the screen and go through each of the table names. One of the interesting things here would be the seat layout. What this means is, or what actually it is, you guys must have seen that when you are booking for that seat layout, it says theater here, and then the type of the seating arrangement. Now obviously in the seats, we have each of the seat indexed technically, and even earlier when I was talking about the bitmap here also we have the different seats represented as bit sets, but this is more about the layout. So for layout based on the type of the screen, this will be a .jpg, like a URL to it, basically URL to the JPG. I thought of just saying it out loud because otherwise rest each of the columns you can guess by it. For example, movie ID, this will be a UUID, these are varchars, most of them, and if needed some would be enums. Here I don't see anything enum other than the status segments, and here also I have listed out what the status are, and in shows they will be mostly fully booked or something like that, of those sorts. Otherwise this is a pretty normal table structure and schema in this post or like a SQL database. Something else also that I like to point out or want to point out here will be, in this section there is already a booking ID. This is acting as a foreign key over here to the actual booking. By default it will be set to null, and then only once a booking is confirmed, then this will be set, which is referencing to this particular booking ID. But something apart from that, are the indexes, because this will be a very heated table. All the queries are coming over here. So what kind of indexing that we set? This again would be something that should be of concern. One would be automatically the booking ID. The other should be, if I want to ask like how many seats are available, my question is how many seats are available. How do I quickly say it out loud? Then I will do some query where I say that for a particular show ID, what is the available, right? So that means my indexing would be on show ID and status. Now, this is a very good exercise actually. If you are working very closely with tables, you should start understanding how indexing or indices are built up. So this would be the solution to that. And the other question would be, or this is actually something that will come up later. If there are expired reservations, now what are expired reservations? Give me some time, I'll come back on this topic, but think in this way that I have made a seat as a candidate. I have gone to the booking phase. So basically, seat selection, reservation, payment, booked. So this would be the typical flow. Right now we are in a normal candidate for reservation, but then abandoned cart format happened where payment did not happen and it did not get converted into book. So in the table, it will be, for now the status will be reserved. It has to be cleaned up. So our cron job or whatever format we are doing, how do we find out that when do we have to clean it? Like if the cron job is running, what logic will be there? It will find out that when was, like, it was reserved by whom and it was reserved when. Mostly it will be like a user basis. I'll come to that design. So if particularly one user, let's say U1, had started this entire journey, then I will be asking that, hey, so revert back the status. So basically it will be like update status in seats where reserved by is equal to the U1 ID and reserved at minus now the current time should be greater than equal to whatever time, let's say 10 minutes I had set. After 10 minutes timeout if this is not there. So I mean overall, if I have to write down the query, the cron job query would be something like update the name of the tables, let's say here in this case is seats. Then I will be doing a set what? I'll be setting the status to available again. And anything else do I need to set by? Yes. Reserved by, sorry for the handwriting, equals to null. And anything else also reserved at equals null. Anything else? Yeah, I have to now do the search condition where reserved by equals to the user ID. I mean here I am referencing the user by U1, but it will be a UUID. And this particular logic that I had told here, I'll copy it from here. Okay, sorry. And I'll paste it over here. So there you go. This is a typical format of constructing a SQL query. Now you can pause the screen here for some time and again observe it. But the main reason is, here you can see where we are putting a reserved by and reserved at. So automatically our indexing will happen here at reserved by and reserved at. So overall, this was something that I just wanted to point out generally in indexing. In many other designs, I generally talk about Cassandra or DynamoDB, and there I talk about the primary key and sort key. And again, I go by the same concept of exactly what is my search pattern and then how do I put my PK and SK. So similarly, I thought here also, because seats table is a very hot table, so what should be the exact indexing keys here? Booking ID being the default one, like, because we want to, again, if you want to understand what it will be for looking up, this will be for looking up seats in a booking. Now this is the primary key. Automatically indexing happens on the primary key. This is for searching based on a booking. Generally when, like, via the QR code, when that status is retrieved, okay, not even QR code, in our own admin side if we are checking for or something, so then booking ID. But otherwise these are the main questions: how many seats are available, and when our cron job is running, which has to clean up. Again, I had told the scenario. Now exactly from here the abandoned cart issue starts, but again before that we have to actually solve the major issue, that is when two users are trying to select the same seat. Because life is very good when, again, I'll draw this diagram here, A, B, C, 1, 2, 3, 2, 3, and these are the columns, these are the rows. User 1 says that he wants to select A1, A2. User 2 says that they want to select B1, B2. But user 3 says that they want to select A2 and A3. If user 1 and user 2 do a query, it is very easy. And what that query would be like, again, time I'll be directly pasting here the actual query. Now just minimizing the size. Here you guys can observe remember I had taken seats table name, so whatever the table name is, main thing is what we are doing, we are updating the table, setting the status as reserved by the particular user, reserved currently, where seat ID is all these values, and status is available. Now there are multiple things. From this point onwards, things start becoming serious. Not because the system is complex, because how SQL works and what things are going to happen at this point. This is from user 1. Or in this case, I said it as user 123 as the ID, but consider it as the query run by user 1. Similarly, user 2 will be running a query. User 2 will have everything same, except there will be user 2 over here, basically user 2, and the seats will be B1, B2. And for user 3, it will be A1, A2. I mean, you get the point that in the query these changes will be done. Now, this query in itself is fine. Why? Because we are doing a check over status available. Remember, we have gone via this concept that there is an available, reserve, and booked. If we do a state diagram, again, these also become very important because the design is very simple, but it is the internal details or the implementation which will help us in the double booking, which is the main, actually the bread and butter of this entire system, where we only want to let one user be booked to one particular seat. Now, a seat is initially available, then it goes to reserved, and then only it gets booked. So we have to strictly follow this, and if it is not booked, then available. From booked directly it will go back to available. In case not this, it will go from reserved to available. It can never go from booked to available. Only this scenario exists only if ticket cancel happens. But let's say we are only in this path right now, normal behavior. So only if the status is available, then for all these seats which have been provided as candidate by the U1, convert them into reserved. But the problem here is, what if I am looking at this place where A1, A2, A3 by U1 and U3 said A2 and A3. A race condition will happen if both the people did the same reservation at the same time, like the query came at the same time, then what? That is where the actual issue starts. Think in one way that A2 and A3, because this query will be broken down by the SQL engine into two steps. First, it will read that exactly this condition, where is it being met? Like, are we getting A1, A2, A3 and are they in available format? If they are, then only do the set. So there is a read and then there is an update. Now think in this way, that I am reading like from a U1's perspective and U3's perspective, that A2 is available, true, A3 is available, true. Same for U3, the same, like the another query that has come, it will also read that yes, A2 is available and A3 is available. So now what? Let's say A2, because of whatever IO gap is there, think in this way that this is U1, this is U2, and this is the SQL engine. Exactly, actually this is only happening behind the scene, you don't have to assume anything. A normal read first happened, like reading, scanning, U2 also scanned. Both scanned almost at the same time. Then some IO gap happened, like IO gap can be from anywhere, from the engine side or the U1 side, and then the update happens. And update happens sequentially in the order in which they have been claimed, A1, A2, A3. So eventually A1 was done. By that time A2 and A3 started, so A2 request came over here already. And now at this point again it will make a request towards A2. Then it is an override that is happening, and it actually happens if you are putting both the things, and if the read has happened at the same time, then they both are reading a stale value. But generally people, when they say, they actually kind of say the other way around. They will make this IO gap very less, so they will assume that the entire thing has happened very quickly, and as per them it is like a one-shot read plus update. So it will become a fastest finger first of who has done the read and update quickly. But no, this query itself has a problem that a read and update, there is a gap by the SQL engine itself, because a read request is done and then an update request is done. And obviously in this case I can show you that U3 will win it, mostly because A1's time will be taken in first setting update. And also, just to make sure, if we are implementing this kind of a simple query, the response to these kind of SQL queries are affected rows. So basically at code level what will happen, you will have a driver function, and then you will have your SQL code written in this format, in a string format or this blah blah, and then you will run this SQL.execute, and then there will be a response you will be reading from it. There in the response you will have affected rows kind of a thing. So if it were this case, I will talk about case 1 and case 2 both. First I'll take case 2, a normal case where U1 came first and then U2 came. So U1's request got entertained and it happened so quickly, and then after that U3's request came and then it got updated. So this will say that out of A2 and A3 my affected rows is 0, and here out of A1, A2 and A3 it will say my affected rows are 3. this will be the first level of defense that a developer has to put. So my if block should have affected rows equal to the number of seats user had presented. If this is the case, then our entire reservation is successful. Mind you, reservation is successful. Else we will go into this path, that revert back. This is one flavor. Now obviously case 2 is the happy path here as well, where obviously when number of seats user had presented was 2, but my number of seats but affected rows is 0, they both are obviously not equal. So we'll go into and say, if even we don't have to revert back, we just have to say that revert back, because let's say we had put A5, then A5 will be updated, so kind of revert back. And obviously we will respond back saying that exactly what were the conflicting rows, so that's not an issue. Now how do we solve this problem? Can we solve it from a SQL level itself, or do we have to introduce anything? So as developers, you first really have to ask that, will the thing that I am using, the tool that I have at hand itself, SQL, will it give me anything out of the box or not? So yes, actually there are multiple things. One is pessimistic mechanism. Why it's named so, we'll come to it. And one is the optimistic mechanism. And mechanism is basically lock. So the overall name becomes pessimistic lock and optimistic lock. First, let's discuss about pessimistic lock, because I mean, this one will be more easier to explain to begin with. Now in pessimistic lock, what we will say is, we will initially go and say that, hey, we want to do this particular thing. We want to set this particular seed for update mechanism. Similarly, here I will put all the other seeds as well. This is from a user one's query perspective. The server would be running exactly these set of queries. Next what? Next we have to actually run the update. So let me put that command also here. Now we can also write it in this way, where seat ID is in similarly the style earlier that we had written. Exactly here, seat ID in A1, A2, A3. That's not a problem. Or we can repeat the same thing 3 times, like into 3. Into 2 basically, or into 3, whatever you mean it, but basically A1, A2 and A3. Having said that, these two are actually, so this itself is locking the row. We have already applied a lock for update. So now if U2 comes and does a read, because ultimately it's not the U2 who is doing the reading, it has already given the entire query. Like earlier, if this entire query was done, then the SQL engine will do a 2-phase, read and then update. So now at this point, a read will happen, then it will see that already, and also think from this perspective, because the server is using same set of logic for every request. So U2 will also run the same thing, select seat ID, and it will give request for A2 and A3 for update. But already SQL engine has said that these rows are locked for update. So any other person who is giving their intent for updating it will not be able to do so. So we have already blocked U2. The time, like if U1 has won this race and gone and inserted itself here, then U1's mechanism will lock, or it's not U1 actually, it's basically the request of U1 via the SQL engine is locking this row for update, and we will wrap it around a transaction. So we will say here start transaction, and here we will do a commit, because again there are different moving parts over here. This can fail, or whatever can happen. I mean, for any reason, even though this should not be a problem, but let's say for any reason this entire thing in update, anything happens in the database engine and fails, so this entire thing will be rolled back. We will again release the lock here as well. We can release the lock after commit, or we can release the lock before commit, like if in case anything fails, we'll roll over. So we are wrapping the entire thing in a transaction. Now again, this needs its own, SQL needs its own deep dive, but as I was trying to say, that we don't actually need any other mechanism, because SQL is giving it out of the box. But everything comes with a trade-off, and that is the beauty of system design. There are multiple other approaches also, I'll come to it, but the main problem here is it will be suffering from DB overhead. Why? Because database connections, or basically the row itself, the row, not the connection, sorry, the row gets locked. Now multiple users are coming, and the DB has literally wasted some time. It's not wasted, it's basically spent some time, but the reason is putting a lock is not that easy on a just saying an update is basically a DB is doing an extra work, putting a lock. And I won't go into the depths, but that operation itself will then create a domino effect, and then it will be going into this update mechanism. So the locking itself will take some time. Think of a scenario where you have around 1000 QPS like queries coming and hitting, like everyone wants to, and we are not talking about a normal movie, we're talking at a global scale about some blockbuster movie which already, like a pre-booking event has already started, and just theater has given its seating window and everyone has just jumped into it. What do we do then? So there is another mechanism called optimistic lock. So let me now say about optimistic lock. Now you guys might be wondering that, hey, what's meaning of optimism and what is the pessimism here? It's from the intent. So what is the intent? First I'll explain optimistic lock and then we'll understand it. Say we introduce a new column called version. So already you guys have seen the column in the seats. So let's say I take all of this, and in that I also add a version column. And by default, I keep the version as 0. So this is the default value, or whatever X value it is. And what I do a query is, first I do a select, I do a seat ID and version. So let me just paste it here. And here we have already got the version, and in this point this is 0. Now the next part will be, now we run an update. So for update also, let me just quickly paste. But before pasting, let me say exactly what we want to do with version. Say I want to now update, and I have my seat ID. One thing is for sure, that I want to convert the status to reserve. So one thing I'll write is status as reserve. I also want to do something else. I want to do that the version should equal to whatever version is currently right now plus 1. It basically is an indication that, hey, I have made a change, or anyone else has made a change to this version. But there's also a reason that I have selected this version. I want to make sure that this is the exact version that I have read. So that means where I'll put status is equal to available, and version is equal to whatever version I read here, so 0. Now obviously what I paste is also the same exactly here. As I was saying, we want to update, we want to set the status to reserve. We are setting version is equal to version plus 1, where seat ID obviously we have given. I have omitted out the state, but obviously we have to keep that status is equal to available. And version, I had started with 1 when I was designing the entire thing. So here version is equal to 0 in this case, because by default it starts from 0. Now where this becomes helpful is when U2 is coming, and U2 is also, let's say, doing a query, and U2 wins the race. Basically it will do a select first, it will also get the same version, it has version 0, and then it is running the same update mechanism. And for A2 and A3, or in this case let's say A1 is the conflict, just to make things easier, it has made the change already. So now the version for the seat column, like for the seat row, everything is there. This is the version column. Here instead of 0, it has now become 1. But my U1, this is from a U1's perspective, U1 had read it as 0, right? Now when it is going to do an update, again a read is happening, this read, right? Here I said that my version should have been 0, but I see that version is 1. That immediately gives a signal that somebody else won the race. And that is where this is called an optimistic lock. Why optimism? Because I, like as a developer or as a system, think from a system's perspective, as a system, I am optimistic that there will not be any such cases of conflicts. There are very light chances of conflict. So I will say that, hey, why not let's start with the entire process. I will go and directly start updating. Obviously there is one process of reading the version first, but I will immediately start updating my seats, and I will see that, hey, if my current version is not same, then I won't go ahead. So what happens is, let's say for any reason U2 wins the race, then U1 will get rejected. It starts its mechanism, but it gets rejected. Pessimistic lock is from a pessimistic, like how a pessimistic person behaves. They think that there will always be conflicting chances. That means I will always start as a entire transaction mode first of all, then I will lock the entire row for update, so that U2 can never win the race at all. It's me who read it, who took the lock, or whoever comes. So basically we read it in our threads also, that if there are two threads, T1 and T2 both come, whoever gets into the critical section, they lock out using mutex the other thread. So in this case it came first, it locked it out, and then it went ahead. Here the locking mechanism is coming via the version column. It's not truly a lock, it's more like anyone who wins the race, they put the version, they change the version number, and then they go ahead. So the other person who might have started early, even due to any reason, now they will again make an update. They will actually check that if the version matching or not, and then they will see, oh, the version is not matching, and that is where they will then reject the entire. So basically this query will not run. It will just return back saying that it did not run. That is the affected rows obviously will be 0. It's not an error basically. It's more like a response will be with affected rows equal to 0. So from this itself, you might have understood that where we might have to use this when the number of conflicts, even though I said that say 1000 QPS is happening at any point, the user experience in optimistic lock for a 1000 QPS issue will be the system is unnecessarily initiating an update call to the engine, and then ultimately it goes and loses out at the version check. But here, even though that database is taking time, which obviously it is taking time, but then because of the locking mechanism, there are all the chances are that all the 1000 queries that are happening, or any X number of queries, they all will be for sure going through the correct path. It's not like at the end moment they will get cancelled. It will be like initial query itself will reject the entire scenario, or it will go to the entire end and then get committed. That's the binary case over here. So for a very heavy scenario, for example, when there are like very famous events happening, or in case of our movie booking system, then we will go with a pessimistic lock. But hold on, it's not necessarily true, because there is another thing we will be introducing soon right now. I would suggest we can go with pessimistic locking. Optimistic are not for these scenarios. Generally we can go for examples where there are much lesser traffics. But what if I say that, hey, this is my booking service. It is going and reaching out to DB, who is taking the entire load. What if I say that no, let's first divert it to some other mechanism who can quickly say me that, hey, is it even locked or not? I mean, is it even available or not? And if it is available, then only I will reach out to my DB for the entire mechanism. What if I can do that? And yes, we can do. That is where Redis again comes into picture. By now, for every mechanism you might have seen, for every system design, that I have talked about Redis, and yes, it is a very powerful tool. So I have drawn it red because I'm making sure it is Redis, like from the color itself you can understand. What we will do is, we will go by the concept of a distributed lock, or in this case, you can just directly say what we are going to do. I'll put a set, then I will put the ID, I'll mention the syntax of the ID, and then the main thing is nx not exists, and then I put a expiry, this is expiry, and then 10 minutes. Obviously, this is not 10 minutes, like the exact syntax is not 10 minutes, but let's hold on to it. Here, I will say show ID and seat ID. That's it. This itself is more than enough. Why? Because say user 1 and user 2. Again, right now, for sake of simplicity, it's A1 that both are trying to book. U1's query came first. It went into the Redis and it will do the same thing. Set this particular, for this particular show, this particular seat ID. The main reason I have to name it in this way is because I want to make the key ID unique. So show ID is unique and seat ID for that show. The combination of show ID and seat ID becomes unique. Now, if it not exists, then set an expiry for 10 minutes is your TTL, time to live, and the response to it is 1. Now, when U2 goes and tries to do the same thing, because it already exists, so this NX will kill it and the response will be 0. So immediately, and this is very fast. Now you have to understand that this is all Redis. The power of Redis is everything is in RAM and it's very hot, so the queries will be very quick. We only go to DB when we have to do, and there is a IO bound operation. DB takes time, and there is again connection pool and lot of things. We don't want to overwhelm the DB with so much stress when we can do it quickly from Redis. And here we don't even have to worry about memory, because at the end this key will anyways expire in 10 minutes. So think in this way. My user 1 or any normal user via the booking service, the request comes, it reaches out to my Redis by setting that lock. If good, I set it 1, and then I go into the DB and then started making that update. Here again, now we have any choice. We can go by the optimistic lock mechanism or pessimistic lock mechanism. To be honest, we have to still go by the lock mechanism because Redis can die. Now, something which is very powerful has its drawback, that Redis can become the very problem that it is trying to solve by at times going OM, or the cluster has some issue. This entire what we say in cap theorem, partitioning happens because of some reason, that either the Redis has collapsed or there was some partitioning in the network because of which this is not able to reach. Then we have to reach here. So now we can think again as a developer. Obviously, I have said what pessimistic lock is and optimistic lock is. So it can be any of the combinations that we are doing here. And via this, we absorb all the hit rate. Now all the queries which are conflicting in nature, in case, they will first come here, quickly get resolved via this, via the 1 or 0 binary concept. And once there is a 1, then only reach out to the DB and start making an update. So the main reason why we introduced this, because remember, the right path, this all is under the right path. And here we want to actually decrease the load as much as possible on the DB. DB is a very sensitive scenario, and at the same time, we don't want 2 users to be on the same ticket, like getting booked on the same ticket. We were already doing it via database, but introduction of Redis is not mainly because at a scale of FIFA or like very popular events, that is when this becomes very handy to absorb all your load. There are 3 states: available, reserved, and booked. We go via strictly available to reserved, and from reserved to booked. Now, this happens only once payment is successful. This is payment success. What if I showed I want to do a booking, and then I finally don't do a booking, or my payment is failure. Payment failure is still a better case. I exit, which is the abandon cart, which I had said earlier that we will discuss about this. Why? Because when payment is failure, which actually is a signal that is caught, that is still much better, because say what will happen if success, else fail, we can still do a SQL query to revert the entire scenario, or basically revert the changes in the seats table. If needed, I will also put a SQL query for this. Not a big deal. I'll put it after discussing about the abandoned cart. But yeah, just removing this part again. Here we go. Now we have enough space. So consider that we are in our reserve scenario. Why? Because again, going from an available to reserve is now changing from reserve to booking. And if we have gone to reserve state, what if I have abandoned my cart and then there is seat A1 and A2 which are left hanging? Because remember, all the updates that we are doing, the main conditional logic is that I only do it when my, obviously in those SQL queries I did not write it, but in my where clause, the status is available. That is a safety check I am putting, and from that available to reserved state, we are converting it. Obviously here I haven't done it, my bad, but obviously here availability check should have been done. So now that they are available and they have been converted into reserved and set in a dangling state, what do? Initial or something very quickly that should come in a developer's mind, or in general engineer's mind, is that they will run a cron job. And very good, that is more than enough. I create another service or like a cron, I interact with this DB, or let me just cleanly draw it. There we go. So now we have a cron which is working on it. There is no such problem in it actually. The only thing is cron happens periodically. Every 5 to 10 minutes we go and we do a query, and what this query will be actually, so one thing is, let's say I don't number it 5 to 10 minutes, every X minute, hour, whatever schedule we put, we go and clean up the DB. But the query for that cron is something which should be kept in mind. Remember, sometime back I had already said that we are putting an indexing over our reserved by and reserved at here, and the SQL query exactly. So let me just copy out this part and take it over there. Now something to worth observe is, we are doing a where clause over a reserved by and reserved at. Obviously we have set our index on these, but then if there are so many seats available on the table and there are multiple, let's say millions, I mean the table keeps growing and growing. Obviously at one point we will also remove the table, but think from a stadium perspective which has like around 1 lakh capacity, and right now this is the one which is going to be booked. A where clause during cron job, when already there is a booking service working on the same table to do write updates, there is another cron job worker who has to come do a scan first on this basis. Obviously indexing has been done, so not an issue, but still, and then making a query. Once it has got candidates, let's say this and this, then it will go and then do the update. It will revert reserved by and reserved at and put the status back to available. Can we do something better? This itself is very good, like no problem, because we have taken care by doing the indexing. But can we do something better? And yes, we can actually do something better, but at the cost of a new design getting introduced or new component getting introduced. So think in this way. Let me just copy the above diagram and bring it in a clean page, and then I'll introduce the new component. So here we go. When we have already got our, we have put the set nx, I mean I'm not writing the same thing again, but set nx, ex and the ttl. We will also introduce a queue. So let me draw the queue in this way. This is your normal, I will mention it as delay queue, but it is nothing but a SQS, or I will discuss actually in depth further. And there will be a cleanup worker. Remember earlier we had introduced a cron here. Think that it's the same cron, but now it will read from this queue and then it will interact with the DB. Obviously I should have drawn it in the correct way. Let me clean it. There we go, much better. So say there are, the moment I am setting my particular thing, I also keep it as a message in my queue, and this will be picked up by my worker. Now what we actually do is, if this is say AWS SQS, I mean obviously SQS means AWS SQS, queue, message queue, we put something called, when putting that message, we put something called delay seconds. What it is, we'll come to this. It is that queue object. We put a body, the message basically. Here we pass the booking ID. Actually in this case it's more like a reservation ID. And we pass the value, so whatever it is, 1, 2, 3. And the main thing, delay seconds. Let's say 600. Why 600? Again, remember here we have put TTL as 10 minutes. Basically I would have put it as 600 only. But okay, that doesn't matter here. I'm just going by the exact syntax. This is in seconds. So 600 seconds is equivalent to 10 minutes. Now this is of actual importance. This means even though I have put that message into the queue, this will not be visible until the 10-minute marker from the time the message has been introduced into the queue. This is invisible to the worker here. Now this automatically acts as a trigger. The moment I have set here my key for my 10-minute expiration, I have also set it as a timed parcel message over here in my queue with a delay second of 600, that is 10 minutes. My workers are already listening to the queue. Any time it crosses the 10-minute mark, it automatically gets visible here. So basically, let's say initially there were 5 messages, out of which these are invisible, and now these become visible. So worker will start picking up immediately each of these messages, and it will directly do a targeted, here it was part of cron query. We will only take, we will forget the entire reserved clause. We will just say update seats, set status available, and just for the sake of, we will put a where condition, but we will not have to do a necessary scan. We will just have to put a where reservation ID equals to whatever we have. That's it. Now you must be wondering that, hey, there was no reservation ID over here. True, there was no reservation ID. Either we can introduce a reservation ID at this point, that is a good way to go, or otherwise in the Redis layer itself, you can put, when you are setting up this particular expiry, also put a set along with the show ID, time ID. Actually, not show time, but more like we'll be putting the reservation and ID, like whatever 1, 2, 3 it is, and then exactly in our string literal quotes, the exact ID 1. These are basically the seat IDs, seat ID 2, ID 2, blah blah blah, and so on. We can do it, or we can also use our Redis lists as well. I'm not going into the nitty-gritty details over here. I'm just highlighting it with a different color. Yeah, and we will be good to go. Because we only have two choices here. Just to mention, like choice 1, this is not case, this is choice. We put a reservation ID as a column. Or choice 2, put reservation as a field in Redis. Choice is us using list or using key value. I mean, list is going via rpush, if I'm correct, yeah. And key value is using set. Ultimately, it doesn't matter if you are using set and there are multiple seats in that reservation, it will be a string with escape literal. So again, rpush is much better here. In this case, like the only caveat to it is, if we are doing this, we have a Redis in place, and Redis, always remember, is ephemeral in nature. There can be any network partition happening to reach out to Redis, or Redis cluster dies. In both the cases, our source of truth is gone, our reservation is lost. That is why I immediately had told that we will be introducing a reservation ID column as well. That makes more sense. And then we have targeted it and said that, yeah, now that we are seeing this thing, as and when, like it's like a timed parcel, or like think in this way in Slack or Teams, when we put a timed message, a delayed message, then it will be scheduled. So the scheduling automatically is coming from here. But that is now leading to a new component, the AWS SQS coming into picture. And again, there will be a fault tolerance. Again, it will have its own dead letter queue. SQS gives out of the box. I mean, AWS gives out of the box. But the point is, earlier we were doing via cron job. We already had a worker which will like do a cron based mechanism and run this query, scan over all the DB and revert back. Here we are doing that targeted. We don't want to target everything. We only want to target over the reservation ID, particularly because we put a reservation ID over here. So via this, we will be finding out that, hey, only these seats are the one where we have to go and make those changes. That's it. Can we do something else without going by the queue process? Yes, we can actually do something. Again, Redis to the rescue. Now, this is again how you smartly think about what you have at hand. This does not come very intuitively. It's more like there is something called zset, which is the ordered set in Redis. Like if you insert 1, 2, 3 element, I mean, if you insert 1, 3, 2, you get it in an ordered fashion. So how do we use this ordering mechanism? Let me explain. First of all, there is a syntax that you should know when you're adding something to the zset. Zadd, the name of the key, then the score. Score is via which the ordering will happen. So the score, and then the member. So key is basically, for example, if I name my key as reservation, and then I have different members. So ID1, ID2, these are the different members. So how will I write it? Zadd, then my key name is reservation set. Then what will be my score? I'll just put a blank over here, placeholder. And my member is the particular reservation ID. Here, res123, like the current reservation ID. The score will be my current timestamp, TS, plus the TTL, the 10 minutes, or let's say 600 seconds. Because this will be an arithmetic. So let's say current timestamp is something 17842330000. And actually, fun thing is, from this you will understand that exactly when did I record this thing. So anyways, fun fact. And here I added 600, so it will become 17842333600. Hey, but by the way, this can be a fake number also, so please don't mind. But fun fact, you can go and check that what exactly this Unix timestamp is converted into the current IST time zone. So now what? We have already added this thing to our set, and similarly we have added other things also to our set. We have to do a ranged query over this set, and that too we will do it using z range by score. So I mean, this is a full word. Then again we pass the reservation ID name, so here reservation set, then minus infinity and the current timestamp. Say in this case it is something called 233, say 800. Knowingly I've kept it better. Now exactly what is the exact syntax? The same thing, the key, the min value and the max value. So in this particular inclusive range of min and max, give me in sorted fashion all the values in this particular range. That is what we have done a query. So using this scoring mechanism, we get in sorted fashion all those keys which have already expired. I have already put infinity, minus infinity as my minimum value, and max value is the current timestamp. So if anything has expired, I have already set the expiry when entering it. So this happened, let's say at 10 a.m. I put a 10-minute window and I set its expiry to 10:10. And whenever my worker is calling this particular query, it just passes the current timestamp. Let's say at 10:15 it has done this query, and let's say it also did at 10:05. At 10:05 we will never get this particular entry that we have done. Res 123 will not get this answer, but at 10:15 we'll start getting it, because our range was min to max. In that range 10:10 will obviously come. So from minus infinity to 10:15 or like 10:15 range, obviously 10:10 will be one of the candidate answers. So you can do the entire thing instead of writing a entire queue. I've cleaned the board and drew it. So earlier we were going via this queuing mechanism. Instead we can also use our Z set. I'll just change the color, Z set. Okay, this one was because we are using it for the set NX is basically acting as the first layer of defense. And yeah, and here we are doing the Z set because we just want to keep it like, now there will be a worker which will be again doing a cron over here periodically and then making an update on the DB. So let me just change the arrow. Yeah, here we go. So kind of, yeah, this will be handling very easily the abandoned cart issue. So we have done the abandoned cart problem as well. We will come to the payment part after some time. Let's also discuss about the thundering herd problem. That is also pretty interesting. Consider, like, what if it is FIFA and we are no more in the BMS scenario anymore, but let's say it were Avengers movie also. Like, the name or things don't matter at this point. Point is, let's say 10,000 users. The moment things happen in this way, I have a countdown timer going on. At exactly 10:30 a.m. my counter opens, or you can think in the Tatkal ticket system also, this exact same thing happens. Even in TTD, going out of the field here, but Tirumala, Tirupati, Devasthanam, I mean here also if you have to do darshan booking, exactly same thing happens. A particular window opens after which you are allowed to enter or basically start doing the booking for your given inventory or given seats. That is where, because so far the design which we have done, the assumption is that it is always open and the users will eventually come here. It's like in one day, in 1 second, the entire load will be distributed. That's where we had done a 10 to 100 like QPS. In this case, it's like in 1 second itself, aram se 1 lakh QPS will hit immediately, just at the time the counter opens. Server cannot take this load. It will crash very immediately, because how much can our workers even scale up? There will be points when the things will start dropping. Either the ECS service will take some time to warm up and provide more, but then database will become a choke point, because ultimately all our writes will have to happen over here. And also we need to really make some think from a real world perspective. When so much crowd enters, what we do? We then start passing it through a queue. That way the entire rush that was going to come, we have broken it down. And by this mechanism, we are able to save ourselves from oncoming problem. We can easily do it by introducing this entire queue. But before that, let me just clean this, because there are a lot of unnecessary diagrams that I made. Now that we are cleaner, first let me just draw the initial point which is leading to this. We have the client, we have our load balancer. I'll not draw the entire diagram again, but rather think in this way. We have our booking service. The moment we hit a very huge spike, automatically we will understand that this is for something which has just opened itself to the public for booking. We introduce a waiting service, waiting room service. Now rather than directing here, we direct all of it over here to the waiting room. And now we also have, say we have this variable called next token, and say this number is say 1036 or any number. I have just randomly taken 1036, don't think much about it. And we have something called serving up to, and here we have 100. What this means, I'll come just in some time, but think in this way. What if in my service or waiting room, it's like a ticket counter, or like a, not ticket counter, but think a person is standing here and you come, you go, there are other two persons behind you. You are handed ticket 1, he is handed ticket 2, and this person is handed ticket 3. Alright, then once you are handled this, now you are sent to a you are not even sent anywhere. You basically think in this way. This is your entry hall, this is your line, and this is the person who is giving the tickets. You come, let's say you, your friends, and a lot of other people come. You all take ticket from this person and you go into this line, say 1, 2, 3, all these people, and now you guys are standing over here. And then slowly, as the hall gate opens, this person says, okay, 2 people come in. So these 2 came. Now after some time, next these 2 people will come. So this is the entire mechanism which we are going to design over here and develop over here. So that's why I said next token. This is basically the token that is going to be handed out next. And serving up to is basically how much we have served up so far. And we will also handle something in this format. Let's say token, the particular ID and its status. And something of this format, is it queued or is it active? This is a OR condition basically. I mean, I'm just saying it's not even an OR condition. It's like either queued or active. I can put an oblique sign also. Obviously, this service can itself not do it. So again, Redis to the rescue. So as I was saying earlier, that Redis is like a superpower at this point. If you are able to think where you can use it and how you can use it, then a lot of things start becoming making sense. Now we'll draw an analogy. Same with respect to here. This is our actually waiting service. There is a person here, and this is this Redis person that we have drawn. The moment a request comes, the first thing is I give my next token at hand to this service, like this request, and I increment it. I just do INCR and write the next token. Just that's it. This is an atomic operation. So even if multiple requests are coming to me, no one gets the same number. That issue is already taken care of using the atomic nature of the increment via Redis. So things go sequentially 1, 2, 3, 4. Everyone gets a different number, and whoever gets which number, here people came in the ordered sequence. Let's say random people were coming. So now let's say this person gets 1, 2, this person gets 3, this person gets 4. So the arranging needs to happen here. For that we will use a Kafka. Let me just copy this part, or let me just think from a let me just draw from a waiting perspective. Waiting, there's a Redis, and we have already spoken here. Then we have a Kafka, because immediately from here all that load of 10,000, like as and when people are coming, just start entering them using the token ID here into the Kafka. And this uses the FIFO concept of basically doing a structured ordering. If you want to know about Kafka, I have already discussed in some other videos which I will show in the top right. But otherwise it needs its own deep dive, which I will be doing later on. Having said that, from the waiting service, we went to the Kafka service. Basically not service, basically we have put all our things into the Kafka. We will have a worker over here. It will start extracting topic. So basically it's reading on the topic of Kafka, and it is taking out the workers as and when it is programmed, or it's basically designed in a way that it matches with the exact rate that our backend service can take. For example, if we do a stress testing and we come to know that our backend can handle 100 QPS, then what we will do is we will let our worker only read our offset till the first 100 at one shot, and then for the next entire 1 second we have taken this 100 and we will only service this, and then in the next 1 second we'll again take 100. So this is how we tail the entire chaos of 10,000 per QPS to 100 QPS via the Kafka and the worker. Kafka is the one which is ordering it and pushing everything, basically working as a shock absorber, and the worker is controlling the crowd rate. Now, the moment worker takes, let's say this, and it had got a token ID of say 1036, what I will do is, this will also interact with my Redis. So I will draw a red line over here. Interactions I will now show with a red line. It will just say that, hey, status of this particular 1036 set to active. Obviously we had put our status symbol as this. I mean, this was the key. I will just convert from queued to active. When we were entering this particular thing via the waiting service into the Kafka, then that 1036 status was basically queued. Now we are changing it to active, the only difference. And immediately, because we have converted it from queued to active, we can just change it to serving up to number to 1036. So basically this will act as a global indicator that how much has been served so far. This will come handy now exactly because the user also will be able to understand. So what exactly is happening is, this is the browser of the user, and a continuous browser will be doing polling, because initially it had done the moment it had gone for booking of this particular, let's say Super Bowl or whatever SB we say, whatever ID it is, ID 123, it had gone into that sequence of post and then all that event ID and then reserve. Immediately it hit the API gateway, and API gateway via the L7 load balancer, it understood that okay, this particular event should be right now part of queuing mechanism. It had passed it to the waiting service. This is the client user. Let me minimize the diagram. So at this point, the working service will be returning with a state saying that, hey, this is your current token, whatever we had given that 1036 value, and another kind of page will show. The page will look something like this, that n people already in queue ahead of you. So remember we had said serving up to, right? So this serving up to number will come handy. browser will do the arithmetic and say that n people are standing in front of you, and your turn will be next. The moment it comes to the point that there are, its chance comes, and I will also discuss about this as well. So 1036's chance comes, then it will go to that exact scenario where it will now reach to the booking service. Here we had drawn earlier this booking service, and then obviously it will hit the DB and all those things. We're not going into that depth, but let me just introduce a few more things then. So here we go, we have a cleaner diagram. Now think in this way, I'll just repeat the steps and I'll write it much more cleanly. We have user who is coming here and it is getting redirected to the worker. So this is the waiting service. I'm sorry for saying worker, so it is going to the waiting service. Now the waiting service will first of all see that, okay, what token it has to be provided. It will reach out to Redis, and now I will have a number here which it will read directly. So it will be next token and the status ID, and it will be queued or active and seen up to, serving up to. So let's say we are the first one. So we will put initially the next token is set to 0, or initially it is set to 1. It asks for the Redis for the value of next token, then it will run an increment on this next token. So it will change. So basically this request that we have, it entered over here and it is given the token ID of 1, and in the Redis we have set the status of 1 to queued. First of all, this much is done. Now when another token comes, then we give it a 2 and we do another increment count, and now our next token counter here is kept to 2, and another request comes, it is given a request of 2. Similarly the worker, it is also open to take or ingest, and it takes in 1 over here. So what it will do is, first of all it will set the state of 1 to active, and it will also set serving up to as 1. Similarly, when it will take 2, it will put status of 2 as active, and it will put serving up to as 2. So ultimately there are these 3 variables which keep changing. Next token being actually done by the waiting service, worker service playing around with the serving up to and changing the status key of that particular token ID, queue to active. But think in this way, the user, its own window, or like the interface, it needs to show slowly, right? What is the after every 2 or 3 seconds you will observe in such kind of scenarios, queue will say, so your position in queue is this much, like whatever number is there. How is that happening? So this is also doing a polling mechanism. I'll show in this way, color change. It will reach out, but actually rather than reaching out to worker, if somehow it can reach to another service, makes more sense, because it is anyways getting bombarded with all these requests. Like already I had say 10,000 requests. So we will again introduce a CDN over here. At this point CDN and Redis cache both make sense. So but obviously Redis you cannot reach directly, so it is basically CDN. All these requests will be actually redirected to CDN. I'll kind of clear this space so that it makes more sense. So actually this worker, I'll highlight it, when it is making update over here, it is also at the same time sending the same information to the CDN. Now the worker, or basically the user, will actually be doing a polling here to reach out to CDN to exactly know that is my token number less than equal to serving up to. As simple as this. So if no, then wait, and if yes, then request entry. At this time my browser, the moment, so basically the browser will understand, yes, if it has gone to yes, then it will do another I'll use this color only, or I'll use a highlighter. It will again do the same query post. Now again the load balancer. So earlier the scenario was that there was no token. So if it is a yes, then it will do a check from the Redis itself that what is the current status of it, active or not. If no token, then it gets redirected to the waiting queue. But in case this token is present over here with the status of active, that means we get a go. Why? Because now from the Kafka, it has been consumed into the worker, and then given that information has been updated into the CDN via which the user has done the query, and then that it is now asking again for a permission. It's basically like there is no other way here. There is no event-driven mechanism that is going to happen over here. So it will now, the moment it sees that yes, it has got a chance because the token is really less than or equal to the serving up to, it will again do the same query. The L7 will now check once, and if the status is active, it will now pass itself, like here will be the booking service, and the API gateway will be redirected over here. Actually, we have discussed a very important thing via this. The entire mechanism that I had shown over here, we have replicated it properly. So we have also discussed the thundering herd problem. Now final leg of this is, which is very small actually, why I have pushed it later, is the payment part. Honestly speaking, the step here where user is first choosing the seat map, which we have already like discussed. Some seats it has chosen, let's say this and this. Then it moves to next page where it says that make payment. It's basically shown the particular seats, and then obviously there are snacks and other things. I'm not going into it, but the make payment. The moment this person clicks on make payment, we already said that we are putting from available to reserved. Obviously we introduced a Redis cache for it where we had put a set NX, blah blah, all those things. I'm not going into those depth anymore. Now we have to convert it into booking only when payment is successful. Payment gateway and the entire thing is actually not our headache. Things like Razorpay, Stripe, obviously in India there is Razorpay, GeoPay, and other kind of etc. Easebuzz. I mean, I'm not going to the payment gateway detail, but say PG1 or PG2, whatever it is, they provide their own SDK. We just have to implement the SDK. Now at this point, what will happen? This was our Redis. Coming back to again, we had this booking component, the booking service. There was a Redis over here. I mean, Redis is not necessary, but I'm just drawing it to show. And here we have this. We have our load balancer. Remember, we had this post and the particular booking ID, not booking ID, but the reservation ID. So it was more like, let me just paste it over here in the clean place. So this was our okay, pen change, and this will be our API call post booking with our reservation ID, payment method, and payment value, and the response will be this. Mainly this is the main thing. We will create another service called payment service. Simple as now this API will be redirected over here. Again, payment service, because we are using SDK. So in the code, think in this way that the code will use the payment token. This was the token value. Internally, we have to just increment an ID. It's a unique token which is used actually for idempotency purposes, so that if due to any reason there is any problem in the network and the user again retries the same payment, or let's say the user also does not retry, the browser itself again passes that request, or maybe here two different requests come. So for idempotency purpose, each token represents one particular payment happening, and that too for this particular ticket itself. So identified using the reservation ID. So now it will just do a call to the external world. This I will represent as the third world or third party. The main thing to note over here as like developers is this call has a success. It's basically a callback URL. So basically when this payment is happening in depth in the API or in the third party API or in the SDK, you have to pass a lot of things, but at the same time you have to pass the callback URL. Or sometimes they also take, when they are doing merchant onboarding, they take this detail of callback URL. So when you see that a user enters OTP and all those things, that is happening from a bank's perspective and everything, that is handled by this third party payment gateway service. If it is success or if it is failure, both success as well as failure, this entire response is sent back over your callback URL back to your payment service or whatever external service you are putting. So generally what we do is, this is not part of system design, rather it is more like here itself at the browser level. When the success or URL hits, we then do another internal call to the same module. So this was your user in the callback URL. So basically we did not pass the payment service URL, we passed the URL of the booking, exactly the particular page that was open. In that we put a callback or like a different kind of URL. This will again do an internal. So basically the third party thing, I'll show a highlighter. It will do a callback over here. It again goes to the payment module, and then the payment module will finally do an update to the DB. That's it. And your payment is confirmed. Ultimately, there is also concept of webhook, but that is used if in case callback fails. Also at regular intervals, like let's say every 10 minutes or every 20 minutes, generally 10 minutes window, there will be a webhook also coming. It's nothing but the same version of callback URL, but directly to your server. So it is called S2S. I'm not actually going deep dive into payment because this has got nothing to do with payment. Payment gateway or payment design needs its own discussion. I'm just saying so that you guys know that if callback URL doesn't work, because generally if there is a browser, the person is in a bad network or whatever reason, automatically there's a fallback mechanism to S2S within a 10-minute window. I'll highlight why I'm saying this 10-minute. So in this 10-minute window, this webhook will come basically from the payment gateway that, hey, this was the particular token against which the payment was done and we have received it. It was a success or otherwise a failure. Either both the things will be provided. And the payment service will then again do the necessary entry in the DB as we have seen earlier. It will be now confirmed as booked and we are good to go. I will actually draw a cleaner diagram. So just to condense everything into one place, because there have been a lot of choices we have made in terms of the double booking system, optimistic or pessimistic, that directly does not reflect in our system design, but I will draw some other architectures and then we will conclude the entire discussion. So here we have the final picture in hand. I have not drawn the arrow so far because I just want to recap everything. We have these particular API calls. So get movies with the first one. Obviously this is particularly the first time when we open a home page, and for that particular movie, here we will be passing different query parameters. I have not given those query parameters over here, but this passes into the search service and directly hits the Elasticsearch. And then obviously we can cache all of this, so I'll be adding a Redis cache here as well. So now the service is going to hit first the cache. In case not there, then it will hit the Elasticsearch, and then it will go into the cache, like it will go into the cache and then respond back to the client. This is done. Same for this movies and showtime. This can also be indexed from the Elasticsearch, or if needed, we can direct it to the SQL as well. But rather, it can also be indexed into the Elasticsearch, actually, the showtime as well. Now comes the seed part. For the seed, we said that we'll go by the concept of bitfield, and because we are still in the search domain, we can pass it via the search service, and then we can pass it into the bitfield. From here, it will do that query and pass it to the client. This is actually coming from the SQL itself. So the first entry was done, first search was done to the actual SQL DB, and from there it was fetched into the bitfield, and then it was given to the client. Now same for the reservation. Here we come to the booking service. From booking service, we actually first make an entry into a distributed log, and then we go in the SQL and change from available to reserved. The same story, I won't repeat again. Now, once we are going, also at the same time, we will make an entry over here for abandoned cart. Now we have two choices, either we go by the Z set or it's SQS. We can directly make an entry into the SQS, or else we can directly make an entry into the Z set. Eventually the worker will consume, so from any of these, and then make an entry in the SQL, converting that reserved back to available. Now, when there is a reserve, then there is a reservation. So again, I'm not drawing that particular Redis, but that reservation ID will also be mentioned over here, along with the seat ID, which all seats come under this reservation ID. And as I said, we can put a reservation column also here, reservation ID for the seats table, and add the same details in the seats table, whatever we choose. Now coming finally to the post booking part, this is actually making a payment. It will hit our payment service, and it will interact with a third party. From there, we'll get a callback URL. We can also at this point make a Kafka queue, because webhooks will also come over here, and then ultimately it will be consumed by the payment service, and final interaction will be done and pushed in the SQL from reserved. That particular seat will be converted to the booked. So that is our overall picture. Now let me put a diagram with the arrows in the same thing and complete it. Alright, now that I have drawn arrows over here, finally we'll also discuss about the waiting queue mechanism also in one shot. So say we have actually introduced a waiting queue here. It will go to the waiting service, load balancer. Basically, coming back to this diagram over here, a lot of discussions actually happened that we are actually a part of our waiting. We will first be redirected from our load balancer to the waiting based on is that token available in the Redis or not. Now, because the token is not available in the Redis, so from the waiting queue, it will be given a token number, let's say 1, and then it will be passed into the Kafka. From Kafka, the worker will take that 1, it will set the value to active. Earlier it was queued, now it is active, and it will set serving to 1. Similarly, here the user will keep polling, or the browser will keep polling. Polling will happen via the load balancer itself, so it will keep polling, and it will say that the current token that it has, which it had got response from the worker, in this case it was 1 initially to begin with, so it had got 1 over here, and it will check that what is it serving up to. So for that, the serving up to will be again coming from CDN instead of the worker, because a lot of users are doing that polling. So rather than asking this worker, the moment it is changing the serving up to, it will push that value to CDN, and then from the CDN we are doing this number search. If the token has reached the serving up to, or then if it is yes, then we will do a request entry. So basically now we will again go and hit the load balancer with our post for the reservation of the ticket, basically our intent to reserve the ticket, and from there it will again check the Redis just to see and to confirm that is it active or not, and because it is active and the token is present, then it will be redirected into the booking. So let me just again draw those lines as well. And finally, we have all the arrows over here as well. Obviously, I have not drawn the arrow of the LB load balancer to the Redis queue. I mean, it was far, but in my explanation, I've already said this. Or it can go via the waiting service and also confirm this. Can be. It completely depends on how we want to do the isolation in this point. This is not actually the main problem of the system design, but rather the entire concept of the waiting queue mechanism that we have done over here. Technically, the main PowerPoint here was the double booking, for which we have already discussed here different kind of locking mechanisms, and finally going with, in a high rate scenario, introducing a distributed lock of Redis. But itself at SQL level, we have the optimistic as well as the pessimistic locking mechanism. This one done by the versioning system, and here we do the select this for update wrapped inside a transaction. So we start a transaction and we do a final commit, and in this part we do an update before doing the ultimate commit. So these are the small nuances which overall combined help us in doing a high throughput booking mechanism. Again, these all were introduced because of abandoned cart issue, and here we already are handling our payment at this point. So overall, this is the entire discussion on our system like Book My Show, or any booking actually, aeroplane based or for movie or for events, or even in your case of ticket counters like IRCTC as well, they will follow the same concept. So hope you guys like the video. Obviously this has been one of my longest videos so far, because overall the topic has been very easy, which you can understand from my discussion, but at the same time, because it is easy, there is a lot of scope and choices that we can explore in this particular topic. And this pattern of segregating between writes and reads and actually trying to save the system by getting overwhelmed from writes, and the writes is basically in this point of the booking, because most of the writes are happening at this in the seats table for all the bookings that are coming. So hope you guys enjoyed the video, and if you really like such kind of deep dives or kind of system designs, please subscribe to the channel and also give a like on this video, put your comments and share it with all your friends whom you think would actually like the video and learn a lot from it. And see you guys in the next video.